Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 24th, 2025, just 3 days ago. The standout claim is a self-guided tree rollout that keeps or boosts reasoning accuracy while cutting compute, with GPU hour savings from 22% up to 43%, and sampling compute reductions up to 40% at trajectory level and 35% at token level. The paper is titled TreePO, Bridging the Gap of Policy Optimization and Efficacy and Inference Efficiency with Heuristic Tree-Based Modeling. And the implications for model training are quite significant. In short, the method treats generation as segment-wise tree search, amortizes shared prefixes, prunes weak branches early, and improves credit assignment for policy optimization. Also, the authors shared the GitHub repo. It's pretty minimal right now. You'll find the MIT license, a README that says code to be uploaded, and basic repository scaffolding with 2 branches and no releases yet. So the implementation is coming, but not posted at the moment. Alright, the intro just set up why exploration is costly and why better credit assignment matters. Figure 1 shows 2 validation curves and a schematic that contrasts vanilla rollouts with the segment-wise tree. The left and middle plots indicate that adding tree sampling slows early gains, but stabilizes training and lands higher accuracy. The right diagram illustrates branching by segments with a fallback arrow, which reallocates effort to promising branches so weak paths get pruned while shared prefixes are reused. So Figure 2 illustrates why shared prefixes matter. Figure 2 shows multiple rollouts from one math prompt where early reasoning segments repeat, which means many trajectories reuse the same steps before diverging. The colored boxes mark identical phrases like determine the common ratio and use the NTH term formula, so computation could be amortized once. This repeated structure motivates a tree search that encodes shared prefixes once and branches only where uncertainty is high, which reduces redundant key-value cache updates and invites targeted exploration. Okay, Figure 2 showed why shared prefixes waste compute. Table 1 presents head-to-head accuracy with major at 16, which compares GRPO against tree sampling variance across AIME, AMC, Math, Minerva, and Olympiad Bench. Adding TreePO sampling raises overall accuracy from 46.63% to 54.61%, which matches the stability story. Allowing fixed initial divergence reaches 56.88% overall, while more initial divergence peaks at 58.21%, so controlled branching improves accuracy without sacrificing stability. So Table 2 compares sequential sampling against tree-based sampling across benchmarks and reports GPU hours. The table shows that sequential scoring reaches 58.21% overall in the more initial divergence model, whereas tree settings land at 54.67 to 58.06%, which is comparable. The key difference is efficiency, because GPU hours drop from 6.40 to between 3.65 and 5.05, saving 22 to 43%. The fixed initial divergence block tells a similar story with smaller savings but consistent reductions. Wrapping up, 2 takeaways stand out. Segment-wise tree search cuts redundant work while preserving or boosting accuracy, and segment-level advantages improve credit assignment so training remains stable. The broader implication is practical scaling of reinforcement learning post-training, with fewer samples and meaningfully lower compute. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.